This is a problem related with complex cube root of unity. The problem is find the common roots of the equations z cube plus 2z square plus 2z plus 1 is equal to 0 and z to the power 1985 plus z to the power 100 plus 1 is equal to 0. We start with the first one, z cube plus 2z square plus 2z plus 1 is equal to 0, this one, or z cube plus 1 plus 2z square plus 2z is equal to 0, or from these two, z plus 1 into z square minus z plus 1. From these two, 2z is taken common, z plus 1 equal to 0, or z plus 1 and z plus 1 is taken common. So z square minus z plus 1 plus 2z is equal to 0, or z plus 1 into z square plus z plus 1 is equal to 0. So either z plus 1 is equal to 0 or z square plus z plus 1 is equal to 0. So from this one we are getting z is equal to minus 1, and from this one z square plus z plus 1 is equal to 0, we get z is equal to omega and omega square. So the roots are respectively minus 1, omega and omega square. These are the roots of this equation, z cube plus 2z square plus 2z plus 1 equal to 0. Now when z is equal to minus 1, then the second equation, we take the LHS of this one, z to the power 1985 plus z to the power 100 plus 1, that is equal to minus 1 to the power 1985 plus minus 1 to the power 100 plus 1 is equal to minus 1 plus 1 plus 1, so equal to 1, which is not is equal to 0. The right side of this equation was 0, but we are getting 1. So this minus 1 is not a root of this equation. Z to the power 1985 plus z to the power 100 plus 1 is equal to 0. Now we check with the second root of the first one, that is z is equal to w. When z is equal to w, then the LHS of the second equation, that is z to the power 1985, replace the z by omega. So omega to the power 1985 plus omega to the power 100 plus 1 is equal to, what will be omega to the power 1985? You divide 1985 by 3. So 1 remainder, two is the remainder. So omega to the power 1985 is equal to omega square plus omega to the power 100 is equal to only omega plus 1. So 1 plus omega square is equal to 0. 0 is the RHS of the second equation. So omega is a root of this second equation. And finally, when z is equal to omega square, so take the LHS of the equation. Z to the power 1985 means omega square whole to the power 1985 plus omega square whole to the power 100 plus 1 is equal to omega to the power 3970 plus omega to the power 200 plus 1 is equal to omega plus omega square plus 1. So 1 plus omega square is equal to 0, which is the RHS of the second equation. So omega square is a root of the second equation. Omega is also a root of the second equation, but minus 1 is not a root of the second equation. So we conclude that the common roots are respectively omega and omega square, this one and that one.